We'll start again, Scott.
Well, we got used to the presentation, so I think I'm in the right mode to continue here. So again, what I want to do is just tell the story of how Siemens Digital Industry Software came to use Cloud Custodian in order to manage our wild west of the AWS cloud that we're in. So today, there's a couple things I want to cover. I'll just give you a brief introduction of who I am and why I'm here talking today. We'll then story of how we came to use Cloud Custodian to tame the wild west of our infrastructure. Then do a high-level overview of our current Cloud Custodian infrastructure. Then just dive in a couple example policies and workflows that we've used to civilize that wild west. And then we'll wrap it up by covering the benefits that we were able to realize by using Cloud Custodian, and then just briefly look at some of the things that are in store for us in the future. So again, my name is Scott Schwartz. I'm located in the Dallas-Fort Worth Metroplex. I'm a senior cloud infrastructure engineer working on the Siemens Digital Industry Software Cloud Security Operations team within the cybersecurity division. I've been involved in IT for about 23 years. Most of that time has been in the federal healthcare space, but I have a wide, varying experience managing and developing applications across a lot of disparate platforms, going back to Rex applications running on ZOS mainframes, all the way to Python applications running in AWS Lambda. Currently, my job is focused on building out the infrastructure and automation to support our AWS accounts and also move us towards becoming, that world-class security operations center. Why I'm here? Well, I was primarily responsible for convincing our leadership team to abandon the existing governance tooling that existed at the time that I came on board and look to embracing Cloud Custodian. And currently, I am still managing the overall Cloud Custodian infrastructure and the development of all the policies that we're executing across our various environments. So, once upon a time, unmanaged AWS accounts littered the vast countryside. Many have told the story of development teams that often jump into the cloud, start doing their work without really having security, first and foremost, and just having a plan of attack. And the term Wild West is often used to describe the environment at that time. But what does that really mean? Well, when I came on board, there were a couple of things that were apparent, and that's why I attribute the way that our cloud infrastructure looked at the time to the Wild West. First of all, there were a number of development teams that were all managing their cloud accounts autonomously. They got in there by varying means, whether it was using local IAM users, maybe some were doing federation. It was up to them. I mean, they decided what they wanted to do, they moved forward and they did it. Additionally, there really weren't any centralized guardrails or policies to enforce that certain security best practices and just common design patterns were used. And just the fact of the matter is that there was a lack of visibility into the overall infrastructure that was being deployed across the entire organization, and having that visibility and the understanding of the security posture was it was non-existent. So that led to the creation of the Cloud Security Operations team that I became a member of. And at that time, the skill level of those that were working in the cloud was not that great. I'm talking about the members that joined the security team. So we really needed to jumpstart our experience and start looking at tooling to help us secure the environment. And then there were also some critical business decisions that were made, which really required that transformation. The primary being that the organization as a whole made a decision to take the applications and software that were being developed in a traditional means and making them available as SaaS applications. And in order to do that, that required us obtaining various industry recognized certifications, including ISO 27001, SOC 2, and things of that nature. So implementing security and being able to centralize a lot of those operations became paramount. And that's when we looked at some tooling. And when I came on board, the commercial cowboys were paid to wrangle in that cattle, so to speak. We were able to utilize that software to effectively put out some policies, implement them, and start applying security across the organization, which at the time was probably about 100 or so AWS accounts. We did things like making sure buckets weren't open to the public, security groups weren't open across all ports to the entire world, things of that nature. But after time, even though the tool really helped us out to kind of wrangle the cattle once again, so to speak, what we noticed was that the AWS infrastructure costs alone was exponentially growing. So not even the cost of the tool itself, which by far was pretty costly, but just managing that tool was becoming just a management nightmare, and the costs were growing out of control. Additionally, there were numerous features that we would consider, basic features that we needed, such as, email communication, informing users and teams of changes that were made to resources, stuff like that. Features were promised, never delivered. And as a result of that, there became this kind of friction that existed between the security operations team and the development teams, because of things like modifications being made to resources and them not even being aware of what's causing it. And lastly, as we would utilize the tool, we'd encounter various bugs and issues with the product, and after reporting them, be several months before they even recognized it as an issue and applied some sort of fix. So because of all these reasons and many more, I worked with leadership in order to convince them that we should abandon the commercial tool that we had procured and move to using Cloud Custodian, as it solved a lot of those issues that we were experiencing. So from an infrastructure perspective, this kind of gives us some insight, this diagram here. It's a little busy, but I think there's a couple things to point out. First, you'll see that the entire infrastructure is based off of AWS native serverless services. That's one key there. The second is that we have two primary modes of operation. There's a periodic flow by which policies are executed centrally from a code build environment. That's what we decided upon at the time. And those policies execute at varying frequencies, whether it's hourly, daily, monthly, so on and so forth. And then there's the real-time policies that execute based on events that occur in the environment. And those policies are all deployed into the child accounts of the organization as Lambda functions. So that's kind of the high-level architecture that was implemented. But there's a couple of interesting things that, I believe that are interesting as far as how we've constructed the infrastructure. The first is that we've relied on a DynamoDB table to control the type of execution that occurs based on the policies. So what I mean by that is that we have an enforcement mode and then an auditing mode. So policies that would remediate resources would only be applied to those that are enforcement mode, as opposed to just obtaining the resource information that we would need from like an auditing perspective. So we use that table in order to drive that functionality. Additionally, we have automation that is used to provision and provide baseline security of the accounts in the organization. And as those accounts are provisioned, that DynamoDB table that I mentioned, which I'll actually show you an example record of that here in a moment, it adds a record to the table, and it kicks off a code build process that deploys those account-specific policies that execute if the account is to be in an enforcement mode. Secondly, or thirdly, tertiary, we created a custom exception process that allows us to basically exempt maybe certain accounts or certain resources within an account from being affected by a policy. So having that exception process was kind of key for us. And then last but not least, we take all of the data from the policy executions, we ingest that into our Splunk platform, and we provide that access to the Splunk environment to our customers, which are the various development teams that we support. And that data can be used by them to power dashboards and all sorts of alerts. So as I mentioned before, we have this Dynamo table, and this is just a portion of one of those records that exist in the table. And the thing that I want to point out is just, that field there, that circle in red, which is to enforce Cloud Custodian. That's kind of the driver there. As new accounts are provisioned, it's always set into true, which means that when a policy executes, or policies that perform some sort of remediation are deployed to those accounts. And for the periodic policies that run centrally in the code build environment, if it performs some sort of remediating action, those that are in enforcement mode or where it's set to true will be applied to them as well. Secondly, just want to mention that I also stated when accounts are provisioned, policies are automatically deployed to them. Also, if an account is to be removed from the organization, or if for some reason we need to temporarily disable execution of remediating policies from custodian, we can go into this table, set the field to false, and it will basically just decommission those policies and prevent them from running. And a lot of the different fields within that table are kind of used in the org accounts.py script that is provided by the project to build out the accounts listing, which is used when we execute the C7N org mode of operation against the organization. And some of the fields in that table just map over to tags, things like that within that table, so that we can effectively process policies based on some of those tags. So now I just wanted to go in and take a look at a couple of the example policies that we've created, which have helped us out and point out just some of the, some of the interesting facts as far as we're concerned. This first one here is one that deletes IAM roles that have a trust policy, which does not require FA or an external ID. The main thing that I wanted to point out, again, circled in red, is how we're leveraging the ability to look at data outside of the runtime environment. So in a number of our various policies, whether it's Lambda or the periodic ones that run in our code build environment, we have these exception files that are looked at that reside in S3, and allows us to determine at runtime whether or not that policy should execute against the account. If there's an account-wide exception, or if there's an exception based on a resource itself, we have the opportunity to bypass execution as a result. So again, that lends into our custom exception process. And I'm not showing it here, but we've also developed a CLI, a command line interface utility that allows us to, using this wizard-driven approach to creating new exceptions for either accounts or resources within an account. And by using that utility, it builds out this JSON file that's specific to the account that allows us to keep track of all the exceptions that we've created for accounts. And those are then all merged and deployed into S3 via pipeline, and then used at runtime by these policies, as you see here. And this just kind of recaps some of the things that I've just mentioned. Here's another example. This one is one that was developed in order to notify a lot of our accounts, the development accounts, and various members of our leadership organization, both ECR images and EC2 instances that contained log4j vulnerabilities. The things that I wanted to point out here, again, circled in red, the first one, at the time that we created this policy, the ECR image resource didn't even exist. However, we had a need to effectively report against any ECR, images that resided in all of the ECR registries across the organization. So we were able to leverage, the open source nature of the software and design or come up with a custom resource and some custom actions, like applying a policy to the image repository to prevent others from pulling those vulnerable images. We've subsequently, after implementing that custom functionality, we did contribute that back to the project, which is something that we're really proud of. Additionally, here we're making use of the Security Hub finding filter that allows us to apply policies based on certain findings which may come into Security Hub, which we are heavy users of. Thirdly, and it's not really circled here, but the fact is that when Log4j, Log4Shell first came about, everybody was in a rush to really understand where those vulnerabilities existed in their environment, and by leveraging the Cloud Custodian YAML DSL, which is both simple and highly effective, we were able to create these policies. As you see, there's not really much to them there, but we were able to create those really fast and execute those within no time and get a complete picture of the instances that we had, as well as the ECR images that contain those vulnerabilities. Again, this is just kind of recapping what I just mentioned. And the last example here is one that basically removes all user permissions, whether programmatic or console access, when a user tries to interface with AWS either through the console or programmatically when they're accessing it via a Tor exit node. The things of that I wanted to point out here, one is how we're leveraging the Security Hub mode of operation. So this is a real-time policy, and as findings are, as they're ingested into Security Hub, and this one is, as you can see, is coming from a guard duty finding, these policies are executed and then perform several different actions, basically to remove all permissions of the user, and then implement some additional downstream processing, which is based on some of the workflows that we've implemented. So here, what you'll see on the right-hand side of the screen is that we're invoking a webhook, which would basically kick off or initiate a PagerDuty incident, and via other integrations that we have with PagerDuty and Jira and things like that, we were able to put together this kind of overall workflow that we've leveraged and are continually using.
Sorry to interrupt, Scott, but we're running short on time.
Oh, sure thing. So lastly here, this is just an insight into our Cloud Custodian dashboard. Shows, like I mentioned before, our customer base or the development teams all have access to this. They can view the dashboard, get their findings out of it, and set up alerts and things like that. This is just an example of the type of email communication that we're sending out to our development teams. And just to wrap it up, I mean, we've seen a lot of benefits by using Cloud Custodian. I mean, we were able to achieve all the certifications that we needed to. What I mentioned earlier, rather than creating friction with the teams that we work with, we were able to establish trust and credibility, and they actually love the fact that we're using Cloud Custodian and deploying the type of policies that we are. And you can see there that there's a lot of other things that we've done, like implementing some unique workflows, integrations with other tools, and things of that nature. And if we're running out of time, I'll end it there.
We do have one question for you, Scott, from Michael. Asks, any thought on multiple levels of enforcement, i.e. more enforcement for teams with lower maturity levels?
Yeah, there's basically right now, I mean, we have all the policies that we're pretty much executing apply to all of our accounts. What we're trying to do is just kind of shepherd the teams to follow certain design patterns. there's other things that we're doing, within the organization to help out those teams that are less mature, and that goes along with, education and making sure that they're involved with our, cloud center of excellence, and just getting a lot of the information there, but not necessarily applying certain policies to specific accounts. That would be a little difficult. At the time when we started using Cloud Custodian, we were just an organization of, maybe around 100 teams or 100 AWS accounts. Right now, we're 500 accounts plus, and working across all regions and all partitions. We also have, hundreds of accounts that are in the process of migrating out of their existing organizations and into ours. So being able to set up specific policies that just target accounts that are of a less maturity model is not something that we've had to do up until this point.
All right, great. And with that, thanks, Scott. Appreciate you coming by and sharing your expertise.
Thank you.
Next thing we have